When we talk about arriving at concentrations or understanding concentrations for the purposes of drug administration, one of the cornerstones of understanding the process is understanding the units of measure. So we're going to make this down and dirty, quick and simple. Just a refresher for those of you whose math skills might be a little bit iffy, no worries. So when we administer our medications, we always need to remember these words, all right? Our solution is going to be our solute mixed in our solvent. Okay, so what are we talking about? Well, you know this better than you think you do if these words are escaping you. Back when you were a kid and you were making Kool-Aid and you read the instructions for the Kool-Aid, and perhaps it said that you were to measure 4 scoops of Kool-Aid, we'll say call it Ka, in 2 quarts of water. We would call the Kool-Aid the solute, the water the solvent, and the two mixed together were the solution. So basically the dry ingredients, which is the Kool-Aid, and the wet ingredients, which is the water, the two of them, one divided by the other, or one mixed in the other, equals the solution. So that's going to be some definitions to keep in mind. Is the solution equals the solute mixed in the wet medium, which is going to be typically normal saline, perhaps lactated ringers, some form of water, and that water is going to be the solvent. Now when we measure these solutes and solvents, we measure them using the metric system. So on the solvent side, we use the units of measure of liters and milliliters. And the liter is going to be that enormous bag, and the milliliters are going to be smaller increments that comprise the liters. We use the metric system, and a really simple and important component about the metric system is to remember that each unit of measure is divided or multiplied by 1,000 to equal the next unit of measure. So on the right side here in green, if we want to convert any of these units of measure, we're going to multiply by 1,000 to find out its equivalent in the next lowest unit of measure. So on the solvent side, our units of measure are liters, which is, when it's capitalized like that, that's one indication how big it is. And then milliliters, milli meaning 1,000. So you can see right here, just in the name alone, that there's 1,000 milliliters in a liter. But just to do the math, we'll take the 1 liter, we'll multiply it by 1,000, and we know that 1,000 milliliters is equal to 1 liter. Now you can multiply it, or you can move the decimal point. So if we start out here as our 1 liter of solvent, and we want to find out how many milliliters is equal to 1 liter of solvent, we know that the whole number 1, we can always imagine there's an imaginary decimal point to the right of a whole number. Not a fraction of a number, but a whole number. And then we simply move that decimal point 3 places. And I've been doing this for 20 years, where I actually will make these little squiggly lines. I'll move it 1 place, I'll move it the 2nd place, I'll move it the 3rd place. And in between, I have these little humps, and I can put in a number or a 0 in each of those little divots, and I know that I end up with 1,000 milliliters equals a liter. When I want to convert kilograms to grams, grams to milligrams, or milligrams to micrograms, I'm going to apply the same principle. I multiply by 1,000 for each single jump. Now, if I want to jump 2 places from kilograms to milligrams, I don't multiply it by 2,000, I multiply it by 1,000, and I multiply it by 1,000 again if you're going to jump 2 places, 1, 2. But generally, we don't tend to jump 2 places that often. It's certainly possible, but not very common. And if you don't want to multiply 1,000 and then multiply another by 1,000 and end up with an enormous number that's going to be in the millions, then simply move the decimal point over. So if you wanted to find out how many micrograms were in a gram, we've got 1.0 grams, and we want to know how many micrograms that equals. Well, we're going to take our 1 gram, and we know that to convert it to milligrams, we're going to go 1, 2, 3 places for milligrams, and another 1, 2, 3 places for micrograms. And we simply put in all the zeros in our little humps, and we know that 1 million micrograms is equal to 1 gram. Now, if we're converting from small units to larger units, we're going to reverse the process. So if we have 5,000 micrograms, and we want to know how many milligrams that is, number of milligrams, then we simply divide it by 1,000. And 1,000 will go into itself once and go into 5,000 5 times. So we know that 5,000 micrograms is equal to 5 milligrams. Or we could simply say 5,000 micrograms, and then we can move the decimal in the opposite direction. If we don't want to do the dividing, we just move the decimal point. So this is 5,000 micrograms, and we move our decimal point 1, 2, 3 places, and we know that 5.0 milligrams is equal to 5,000 micrograms. Okay? And as long as you keep that clear in your head, that taking a large unit of measure and moving it to a smaller one, you're going to multiply. So you take a large number and you move it to a small unit of measure, you multiply, and take a small unit of measure to arrive at a large unit of measure, you're going to divide. You'll be fine. 3 places to the right, or multiply by 1,000 to convert from a large unit of measure to a small, or divide by 1,000 and 3 places to the left to convert a small unit of measure to a larger unit of measure. And again, the solvent is going to be the dry ingredient in the mixture, the solute is going to be the wet ingredient in the mixture, and the two together equal the solution. See you next time.